Hi, this is Mr. Anderson, and this is part 2 of Atoms and Elements. In part 1, I talked about the history of the atom and how it came to be known as the atom. In this one, I'm going to talk about what do we got in here. So in here, we've got these things. We're going to call those protons. We've got these things, and we're going to call those neutrons. And then out here, we have this cloud of probability where we have these things called electrons. And so this is more of a nuts and bolts. In other words, what do you learn from looking at the periodic table? So let's get started. On the periodic table, you have essentially a box, and that box represents one atom. And so that represents one type of element. And so we'll call this neon right here. So neon's a gas. It's a noble gas. And if you put it inside a tube and run electricity through it, it's going to glow. But what do we know from this 10 and this 20 and this 2 and this 8? What does that tell us? And so essentially what we're looking at is the periodic table is organized according to its atomic number. So the atomic number is going to tell us the number of protons that we have. Okay, what else does the atomic number tell us? It also tells us the number of electrons that an element has, because the positive charges of the protons and the negative charges of the electrons will always equal each other out. The next thing we have is the mass number. So the mass number, the mass of an electron is really, really small. It doesn't weigh much. And so the mass number tells us the mass, or the number of protons we have, plus the number of neutrons that we have. Okay, so what are protons? Those are positive charges. What are neutrons? They weigh the same as protons, but they have a neutral charge. And then what are electrons? Electrons are going to have a negative charge, but again, they're going to move around the outside. And so let's kind of do one of these. And I'm going to use the Bohr model right now, and so this is not really what an atom looks like, but we'll get more specific a little bit later. And so let's start in the middle. So this is going to be the nucleus right here. So if we look at this up here, neon, the 10 at the top, and so that's how the periodic table is organized, the 10 at the top is going to tell us how many protons it has. And so let's say it's got 10 positive charges on the inside. Next one, this is the average atomic mass. And so if you're going to solve one of these, they have to tell you what the mass number is. But let's say the mass number, for example, of neon is 20. What does that mean? Well, there's 10 protons, and there's also going to be 10 neutrons. And so on the inside, we're going to say that there are 10 neutrons on the inside, because the number of protons and the number of neutrons always add up to the mass number. Okay, now let's figure out the number of electrons. Well, there's something that you should remember, and I'm going to write this up at the top. That is 2, 8, and 8, and 18. And it keeps going like this, but for now, let's just remember that. 2, 8, 8, and 18. In other words, the electrons always go in specific energy levels. Okay, so let's go back to it again. So we've got 10 protons in here, so how many electrons do we have? Well, we have 10 electrons, because remember the charge is going to be the same. But those electrons always fill their way up from the inside to the outside. So what does that mean? We're going to have 10 electrons in this first energy level, like that. Okay, so we've taken care of 10, and now we only have 8 electrons left to take care of. Well, how many can I put in the next level? This is why I said you really want to remember this up at the top. Well, I can put 8 electrons in the next level. So I'm going to say we've got 8 electrons in the next level. Now we'll learn in later chapters, that's kind of wavy, that electrons are happy if this energy level is filled, or atoms are happy if it's filled. And so since this is 8 electrons in the outside, this is a really happy kind of an atom. And neon exists just by itself because it's got that full energy level right there. Okay, so that's a lot of stuff. Let's see what we can remember. Let's do something like nitrogen. Okay, nitrogen makes up most of what you're breathing right now, so let's go through it again. So if you look at it, our atomic number is 7, so how many protons does it have? 7 protons. How many neutrons does it have? Well, let's round this for a second, because this is the average. And so let's say that it's 14. So if that's 14 as a mass number, that means we have 7 neutrons. All right, so let's go around the outside. So let's say this is our nucleus. Now let's do electrons. Well, there are 7 electrons, and so you're going to put 2 electrons in the first level. I'm going to put it like that. So draw this first energy level. And so I've taken care of 2 of those, and so now we have 5. And so how many are in the next level? It's going to be 5 electrons in the next level. So it looks like that. This is kind of sloppy, but there's 5 electrons in there. And now you're starting to see why we have these numbers a lot of the time on a periodic table as well. So what does nitrogen want? Well, nitrogen would love to have 8 electrons in this next level. And so it only has 5. And so if it could gain those electrons somewhere else, so this is something that is really important. This is called ammonia, and ammonia is NH3. And so that's 1 nitrogen atom and 3 hydrogens. And so eventually in the next few chapters, we'll start talking about chemical bonds. And so what hydrogen can actually offer to nitrogen is those 3 electrons it can share. And so you should be able to do that with any kind of an atom on the periodic table. But let's look at the periodic table then. How is the periodic table actually organized? If you look at it, our atomic number here is going to be 1. And then it goes all the way, let me change to a different color that you can actually see. It goes over here to 2. And then it's going to go back over here to 3. And then 4, 5, 6, 7, 8, 9, 10. Okay, so the periodic table is ordered according to its atomic number, the number of protons. But now you should start to see why we had to remember that 2, 8, 8, 18. If you look across the top, we've got 2 elements in the first level. We've got 8 in the next level. We've got 8 in the next level. And then we've got 18 as we come all the way across like that. Now, why is it that we have those numbers? Well, again, it's quantum theory, which is pretty confusing. So we don't have to really understand why yet. We just have to know that it exists. But let's kind of walk through this in your head for a second. Let's start with hydrogen. Hydrogen is 1 on the atomic number, so it's going to have 1 periodic it's going to have 1 electron as its outer level. But let's look at another one. So let's look at, for example, lithium. How many electrons does it have in its outer level, or sometimes we call that its valence level or a valence electron? So if we look at lithium, well, lithium is going to have 2 electrons in the first level, and it's going to have 1 electron in the next level. So that's odd. So hydrogen and lithium both have 1 electron in the outer level. Well, it's not that odd, because if we look at the next one, sodium, how many does it have in the next level? Well, sodium's going to have 2 electrons in the first level, it's going to have 8 electrons in the next level, and it's going to have 1 electron in the outer level. And so the number of electrons you have on the outside of an atom really determines how an atom behaves. And if you think about it, in the periodic table, all of these atoms, or all of these elements, are going to have 1 valence electron, 1 electron in the outer level. And so they're going to share properties. And so these are called the alkali metals, and they're metals that are highly reactive. One of my favorite Mythbusters is when they keep trying to throw all these alkali metals into a toilet and seeing them react with water, so you get explosions. If we look way over here on the other side, these are going to be the noble gases. Noble gases, or this group right here, are all going to have filled outer levels, and so they're really stable. Or if you look at these ones right here, these ones are actually called the halogens. Halogens are all going to have 7 electrons in their outer level. And why is life made out of carbon? It's because carbon has 4 electrons in its outer level. And why is water H2O? Oops, let me try that again. Water is H2O because oxygen, which is right here, is going to have 6 valence electrons, but it can grab 2 of those electrons from hydrogen to make H2O. And so how is the periodic table organized? It's organized according to the number of protons in ascending level. But more importantly, it's the verticality that tells us a lot. Every time you go up and down in the periodic table, you're going to have elements that have the same number of valence electrons. And so you see cool relationships like this. Copper, silver, gold, they're all in the same column, and that's because they have really similar properties. Just like carbon and silicon right on top of each other, they all have 4 valence electrons, and so they kind of have the same properties. They're really good at forming bonds. And so that's what an atom looks like, and that's basically how the periodic table is organized, but we're going to spend way more time getting into the nuts and bolts of that and drawing some Lewis dot diagrams a little bit later. But I hope that's a good start. Thanks.